Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically in the previous video we had seen about the student state distribution, right? We had seen that basically what is this topic and basically what are the things that we have in the student state distribution. After that we had even seen two properties about the student state distribution. Now today we are going to see some further properties and even the notations for the student state distribution. Right, but before that, basically, let me just quickly give you a revision that what we had done in the previous video, so that you can just correlate with today's video also. Okay. So, student state distribution is any member of a family of continuous probability distribution that arise when estimating the mean of a normally distribution population. If you draw a simple random sample of size n from a population that has approx a normal distribution with mean mu and unknown standard deviation sigma, calculate t score. T is equal to x bar minus mu upon s upon under root of n. Right, so these were the things that we had discussed. And the first property that we had discussed was the graph for the student state distribution is similar to the standard normal curve, right? And the second property was that the mean for the student state distribution is 0 and the distribution is symmetric about 0. Now moving towards the third property of this student state distribution, I will just write here as third. Okay, let me write it with new color only because today we are starting a new video. Right. So basically now I'm just going to tell you about the shape of the student state distribution curve. Okay. So I would just write that the exact shape of the student's T, and I would just write here distribution as DIST. Okay, there's a short form, right? So the exact shape of the student's T distribution depends on so basically what is the factor firstly on which it depends? So it depends on the degrees of freedom, right? As I have mentioned in the previous video, as today I'm even mentioning that it depends on the degrees of freedom. Let me just come down so that I can see and write properly. Right, so it is degrees of freedom. Right, now I'm just going to tell you that what if the degree of freedom increases, then what is the effect on the student state distribution graph and all that things. Okay, so I would just write here that as the degrees of freedom, I'm just going to talk about this degrees of freedom, right? So as the degrees of freedom increases, okay, as this value actually increases, the graph, okay, the graph basically which we are making for the student state distribution. So the graph becomes more. Let me even come down. The graph becomes more like the graph of standard normal, like the graph of standard normal, and okay, this is O, okay, make sure standard normal distribution, right? So basically what I've just told here is about to use about the degrees of freedom, right? Okay, just give me 1 second right here. So basically if the exact shape of the student state distribution depends on the degrees of freedom, and it basically correlates as the degrees of freedom increases, the graph becomes more like the graph of a standard normal distribution. Now we all know that basically how the standard normal distribution graph look like, right? We had already seen these things in the previous video, so I'm just not going to repeat this thing today. Okay, I hope you have basically seen out the previous videos as well. Now this was the third property which we have discussed. Right now moving towards the fourth property, what I could say here is that I would start writing about the student state distribution. Okay, student state distribution has more probability. Okay, has more probability. I would simply write PROB. Okay, so a student state distribution has more probability in its tails. Okay, okay, than the standard normal distribution. Now basically you had a look over this and in the previous video and today as well, that basically we are somewhat comparing that things for the student state distribution with the standard normal distribution, right? So we just write here than the standard normal, and here we just add a distribution, right? Standard normal distribution. Now, basically, what is the reason that it has a more probability in tails? What is the reason for that? So I would just write here because the spread, okay, of students, let me come down this side. Okay, the spelling for spread is wrong. Just make that correct on your side. Okay, SPREAD. Make it SPREAD. So because the spread of students T distribution. Okay, students T distribution is greater than the spread of spread of standard normal distribution. Standard normal distribution, right? So this is the reason that basically let me just like hold on the cursor. So this is the reason that the student's t distribution has more probability in its tails than the standard normal distribution, because the spread of student's t distribution is greater than the spread of SPREAD, spread of standard normal distribution. Right. So these are the four properties that we have here. Now moving towards the next thing which we can say is how to denote all these things, right? Basically, what is the notation for a student state distribution and all those things, right? Let's discuss that thing. So here I would just add on that the notation for the students t distribution. Okay, so the notation for the students t distribution is, and in the bracket I would just write here that using, now basically I'm just using that t as a random variable. Okay, using t as the random variable. Okay, I'm just using this t as a random variable here. Okay, so the notation for the student t distribution is, okay, let me just change out the color here so that I can just differentiate the things a little bit. So the notation is basically, we just simply write t. Now this is basically what I'm just treating it here. I'm treating it as a random variable. So t basically belongs to small t and df. Okay, this is one. This is a denotation. And where basically df is equal to n minus 1, and that n minus 1 is actually the degrees of freedom, which we were talking in the previous video, which was related to the student t distribution. Right? Now, let's have a quick example for this thing. So I would just write here as example. Now let's say if I have, okay, I will just write here this thing. If we have a sample of size n is equal to 20. Let's say I have a sample of size n is equal to 20 items. Let's say, okay, this is the example which I have taken. Then basically, we calculate the degrees of freedom. Then we calculate the degrees of freedom. Let me just come down this side. Then we calculate the degrees of freedom as, now what is the formula that we use? So I had already mentioned that df is equal to, okay, let me just make that df clearly, as I will just put this here, and that is df is equal to n minus 1. Right, now what is this actually n here? This n is actually 20 minus 1, and that will be resulting me here as the answer, which is 19, right? And basically, and we write the distribution. Now distribution, I am just writing that distribution. Okay, now basically I just told you the denotation for the distribution, right? And we write the distribution as t capital T basically belongs to small t, and here as 19, right? This is small t and 19 is basically the denotation for my student's t distribution that I just right now told you. Right, so this is basically how we just denote the student t distribution. Let me just give you a quick overview over this. So I had taken an example that if we, let's say we have a sample of size, basically n is equal to 20. Let's say I'm just given this, okay, I'm just given any size, and if someone comes and asks me to calculate the degrees of freedom, right? If someone asks me to calculate the degrees of freedom, so in that case basically here what I can just apply the formula is, I can apply the formula that is df is equal to n minus 1, right? Df is equal to n minus 1, and n basically I am having here as 20, right? So that 20 minus 1 is resulting me the answer as 19. Now right now above here, just let me hold the cursor here. Above basically I told you the denotion, right? Where it has gone, yeah, here I just told you the denotion for the students T distribution, right? Let me just highlight this thing so that you can even like remember that afterwards also, this thing. And this was finding the degrees of freedom, right? So basically as I just mentioned it, okay, just one second, let me take the pen here. Okay, as I mentioned about the like thing that basically how to denote that. Okay, so that thing can be done here, which I had just written, and we write the distribution T basically belongs to small t and 19. Right. So this is basically what we had studied about the student distribution. So it is any member of a family of a continuous probability distribution that arises when estimating the mean of a normally distribution population. Okay, this is the first thing. After that, if I draw a random sample of size n from a population that has approx a normal distribution, just one second, um, right, which has basically a normal distribution with mean mu and unknown standard deviation, then we calculate the t score, which is t is equal to x bar minus mu upon s upon under root of n. Then the t score follow a student's t distribution with n minus 1 degrees of freedom, right? So t score has basically same interpretation as the z score, and it measures how far x bar is from its mean mu. The number n minus 1 is called as degree of freedom, right? So these were some things which we had already discussed regarding the student state distribution in the previous video, and here are the properties that the graph for the student state distribution is similar to the standard normal curve, and the second is that the mean for the student state distribution is 0 and the distribution is symmetric about 0. And this is basically, if you just get a simple question, so this is basically how you will be solving that simple question, that if you are given a sample size and if someone asks you to find out the degrees of freedom. So you'll be simply applying df is equal to n minus 1, n would be the size of your like sample which you have got, and you simply subtract 1 from that side. Right. So basically I hope that you have a fair and a clear idea that basically how to solve these types of questions and what to apply, what are the properties, and even what is student state distribution. Right. So this is all for this video. Till then, thank you and take care.